Okay, so good afternoon, everyone. So this is the lab tutorial exercises for week 2, floating point numbers. And now you can see that in the very first question, we are talking about epsilon. Okay, so let me share with you my MATLAB screen. So if you have any question, just please put in the chat box. Yeah. So now I put in epsilon. Okay, so epsilon is just the gap between 1 and the next machine number after 1. So would it just 2 to the minus 52. Okay. So now if you put in 1 plus epsilon bigger than 1, then the answer is true, right? Because 1 plus epsilon is just the machine number right after 1. Okay. But 1 plus epsilon over 2, is it bigger than 1? Well, because the machine round off epsilon over 2 to 0. So you see that 1 plus epsilon over 2 is just the same as 1. So 1 cannot be bigger than 1. Okay. So now I'm doing exactly the same thing, but for different numbers. So 8 plus epsilon, is it bigger than 8? I cannot see MATLAB. Okay, sorry. I forgot to share the MATLAB screen. Okay, so you can see my MATLAB screen, yeah? The epsilon, when you type it in, so EPS, then you got 2.2 times 10 to the minus 16, okay, which is the same as 2 to the minus 52. So 1 plus epsilon bigger than 1, you just type it in, you got 1. Okay, because 1 plus epsilon is exactly the number bigger than 1, right after 1 in the machine. And 1 plus epsilon over 2, epsilon over 2, too small, so it got routed back to 0. So then 1 plus epsilon over 2 is just like 1. So 1 cannot be bigger than 1, okay? Well, now I'm doing exactly the same thing, but I replace 1 by 8. So 8 plus epsilon, is it bigger than 8? Can you type it in and see what is the answer? So remember, 1 plus epsilon is bigger than 1, right? But now what is, yes, so 0. Why is that? Why is it equal 0? 1 plus epsilon is bigger than 1, then it's true. But 8 plus epsilon bigger than 8 is not true. So why? Why is that? Any guess? The distance between epsilon and 8 is too much. Well, but okay. So let me. Well, what you say is correct, but not very precise. So let me explain it by pictures. Yeah. So if I share my piece of paper. So you see, if we remember 1, yeah, is just in binary form. It's just 1.00, dot in binary form, right? And then 1 plus epsilon is just 1.00, and you turn the last digit into 1. Okay, so therefore epsilon is just equal 0.0000. The last one is 1. Okay, and this one is the 52 digits, or 52nd, yeah, digits, yeah. And so this one equal 2 to the minus 52. Okay, so that is 1 and 1 plus epsilon. So now how about 8? So 8 is, so if you write down in binary form, it will be 1, okay, and then 000, but now you have to multiply by 2 to the power 3. Okay, so remember, do not forget the power in the floating point representation. Yeah. And so now what is the one next to 8? So the next to 8 is 8 plus, let we call it epsilon of 8. Okay. Is you turn on the last digits. So everything is 0, 0, 0, but the last digits is 1. And then the power is still the same. Okay. So then you can see that epsilon of 8 is 0. Then 0 dot 0 up to the last one is 1. Okay, but then do not forget the power 3. Okay, so then this one will be 2 to the minus 52 times 2 to the 3, which is 2 to the minus 49. Okay, so you see, so now if I draw a line, then this is my 8, and this 8 plus epsilon of 8. Yeah, so a plus epsilon is still somewhere right here. So a plus epsilon is still somewhere here. So it will be rounded off to 8. Okay, and so you can see that if I put it in my MATLAB, so if I go back to my MATLAB, yes, then I put in epsilon. I put in a, well, maybe I put in epsilon 8 first, yeah, epsilon of 8. So it will be 1.77 10 to the minus 15. So it is the same as 2 to the minus 49. Yeah. Okay. And you see that 8 times, so now 8 plus epsilon of 8 will be bigger than 8. Okay, so epsilon of 8 is the gap between 8 and the next number after 8. So, well, before you say that, okay, so why don't I take 8 multiplied by epsilon? Well, this one is still correct, but if you compare the results of 8 times epsilon, yeah, and in this case, they're the same, yeah. In this case, they're the same, but in other cases, they might not be the same, yeah. Okay, so maybe move to the last question. You can see that in the last question, we have 100. So we have epsilon of 100. Okay, so maybe first we just put in epsilon of 100 first, yeah. That is correct, yeah. And if you put in epsilon plus epsilon 100 plus epsilon, then it's not going to be bigger than epsilon, yeah. So now what is epsilon of 100? So this number, and what is 100 of epsilon? It's a different number, you see. So 100 times epsilon is bigger than epsilon of 100. Okay, so now how do we find out what is the exact values of epsilon 100? So how do we find out? Well, first we have to expand 100 in terms of a binary, right? So there's a command in MATLAB, it convert a number into binary. So if I convert 100 into binary, then I got this number. Okay, so let me use this number and put it in the calculation. Yeah, so if I put in, so let me share my piece of paper. So now 100. Okay, so 100 will equal. So we use the same method, right? Except now we have 100. So remember our expansion will be 1, 1, 0, 0.0100. Okay, so in decimal, and this one is multiplied by 2 to the power 0, right? Because it is the original expansion. So you want to put it into the normalized form. Okay, so the normalized form will be 1.100100, right? And now remember, you move the dot 6 places. So 1, 2, 3, 4, 5, 6 places. So you have to multiply by 2 to the 6. Okay. And now 100 plus epsilon of 100 will be, you turn on the last digits. Well, remember, this one, when you put into the floating point number, you have a lot of zeros you have a trail of zero, because remember we have 52 digits here, yeah? So this one, I should say that this one equal 1.100100, but then you have to put a lot of zero here, okay? Multiplied by 2 to the 6. So you make sure that you have 52 digits. Right? Because remember, after the dot, you just put in zero, so it doesn't change the value. But then when you turn on the last digits, so you got 100 here, then 1000 here, and dot, 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 and the very last digit to turn to 1, right? And then you still multiply by 2 to the 6, okay? So do not forget that, yeah? And so the epsilon of 100 will be, so if you take the difference, will be 0. 0, dot, 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 0, and the last one is 1. So 52 digits times 2 to the 6. Okay, and this one is just 2 to the minus 52 plus 6, which is 2 to the minus 46. Okay, so now if we go back to MATLAB, so if I go back to my MATLAB screen, so if I go back to my MATLAB screen, yeah, so I type in 2 to the minus 46 or epsilon of 100, and just the same, okay? So we understand what is going on, okay? Yeah? So you see what is going on here, yeah? So that is the question in part 4, yeah? 100 plus epsilon of 100 is greater than 100. And now the two questions in the middle. So suppose I have h is 10 to the minus 14, right? And I have 100 plus h minus 100. So what should you expect if you take 100 plus h minus 100? So what do you expect? H, yeah. So you should expect that h, because that is the obvious calculation, yeah. But it is not exactly the same. So you see, you got like, so h is 1.00010 to the minus 14. But here you got the answer is 1.42 times 10 to the minus 14. And now if I put in h is e minus 15, which is 10 to the minus 15, yeah? And you got 100 plus h minus 100. So now my h is 10 to the minus 15, but the answer is 0. So there's a big error. So why is that? So why is that big errors? Anyone? So why we have the errors? So if you remember h less than epsilon of 100. Yes, that is very good observation. So because epsilon of 100 is 1.4 10 to the minus 14, yeah. But okay, so it got routed back to like 0, right? So that is one way to explain it, yes. Yeah. It routed off to the nearest epsilon, yes. So but you see, so it's a routing errors, yeah. Okay. And now we move on to the second question. So and but another explanation is, you know, I mean, when you minus two numbers very close to each other, you have catastrophic cancellation. You know, so 100 plus h minus 100. You know, the gap between them is just 10 to the minus 15. Yeah. And if you remember the lectures, and when I mentioned catastrophic cancellation, when you take two numbers, you subtract each other, then the relative errors could be very big. Okay, so if you remember in the lectures, so now I can show you the lectures. So you see, so in MATLAB, there's a lot of draw-off errors, so we have to be very careful. Okay, so if you remember catastrophic cancellation, so let me show you. I share the slide. So you can see that if you look at the slides in the routing errors for the operation in MATLAB, so you see that here. So you see when you take two real numbers, two floating point numbers, and you subtract each other, then you know first it routed off to the machine number first, then it performed the operation, and then when it got some floating point numbers, they routed again. Okay, so we can have some errors. So this for the plus is okay because it can be controlled by some small quantity. Multiplies is okay, multiplication is okay, division is okay. But for subtraction, you can see that if x minus y is very, very small, this upper bound can close up. Okay, so for catastrophic cancellation. Okay, so 100 plus h minus 100 can be very small, you know, so it could be a catastrophic cancellation. Okay. So any question before we move on? So we move to the next question will be, how do we fix this? Good question. So, well, because the only way to fix it is you have to increase the number of digits in the floating point representation. So now in Python, you know, you can have 128 bits for a real number, or in new language like Julia, you can have a lot more digits, you know, so make the accuracy is more than 64 digits. But then the cost is you have to have more memory to deal with the computation. Okay, so think of changing the order calculation. Could be, yeah, but it will depends on your calculation. So one way, so if you look at the tutorial tomorrow, you will see that there is a way to fix the catastrophic cancellation by changing the formula. So we will look at it tomorrow. Okay, so but it will be depends on your problems. Yeah. So any more question? Okay, so otherwise we move to the next question. So the next question is, let me share the next question. So the next question is, so how do you make a part of the surface invisible? Okay, so this one, you just open a script, okay, and type in those 3 commands and see the effect first before I explain it. So this one, you just cut and paste, so cut and paste this one into a script. Yeah, so now let me share my MATLAB. So you cut and paste into a new script. Let me share, maybe I share my screen because you can see my MATLAB. So you can see my MATLAB and my editor at the same time, yeah. So I just cut and paste this one. So let me run it first and I explain it to you. You save it. In this case, I save it like week 2, question 2. Okay, and you hit the run button. So if you hit the run button, then so you will see. Maybe let me make the sphere look like a bit more like a sphere. Yeah? So axis equal. So put in axis equal, and then you run it again. So you see my sphere, yeah. So the sphere has a hole in it. So a hole. So 16,3. So what does it mean here? Okay, so let me explain how the command sphere works. Yeah. So remember in the Cartesian coordinates, okay, the sphere is just x square plus y square plus z square equal 1, right? Okay. But in the spherical coordinates, then I mean, you can relate x, y, and z by this formula. So z x will be sine of phi cosine of theta, and y is sine of phi times sine of theta, and z is just cosine of phi. So anyone remember this formula, right? So you remember this formula somewhere in your vector calculus, yeah? And so this command sphere, okay, will compute So now suppose x, so suppose theta is a vector, you know, a vector of equally spaced points. Yeah, so theta 1, theta 2, and so on up to theta n. Okay, and phi is another vector of equally space. Yeah, and remember, you know how to do it, right? So phi 1 up to phi n, maybe phi n. Yeah. Okay, then when you take the cross product of theta and phi, then you got a grid, you got an n by n grid. Yeah, and in this case, you know, I mean, in this case, then this one is just so if I show you the MATLAB, you see that there's a vector. So there's a vector x, sorry, not a vector, there's an array x, yeah, and the size is 21 by 21. Okay, and the size of vector y is 21 by 21. So you see, because if you take n equal 21, yeah, then x is just a 21 by 21 matrix. Okay, that represents the x points of the sphere, and y is 21 by 21 matrix, represent the points y on the sphere. And then you just use command and you plot it. So then now if you make the point 16,3, yeah, so remember x is just a 21 by 21 matrix, yeah. So if you take row 16 and you take column 3 and you set it to be not a number, then when you plot it, then this one just become invisible, okay, because it take away the point here, yeah. So now the question asks you, how do you make the whole region disappear? Okay, so the region is x less than 0, y less than 0, and z greater than 0. So what is the region? So the region will be something like this region, yeah, because this is the region that satisfy the condition x less than 0, y less than 0, sorry, x and y less than 0, yeah, but z is greater than 0. Okay, so how do we do that? So let me show you at least a partial solution, and you tell me how to complete a full solution. So the hint is you use the find command. So find. So if I show you my MATLAB, yeah. So suppose I have a vector, say x equal 1, 2, 3, 4, minus 5. Yeah. Then I find x less than 0. Then it gives me 5. So what is 5? So 5 is the index of the entries that is less than 0. Okay, so it gives you the index of the entries that satisfy the condition. Okay, so now suppose I apply this idea to what we are doing. Yeah, so I say that, okay, now if I say that ix, so for index x, yeah, is find x less than 0, Then I said x of ix equal not a number. Okay. And now I run it. So if I run it, so you see what happened. So the whole sphere for x less than 0 become invisible. So you got half a sphere, yeah? So how do you apply this idea into the question? So you type in the commands I put in MATLAB and then we can test it. Yes, you have to try it. Otherwise you will not see the effect. The best way to learn a language, you just try to practice, So anyone, so how do you find the region that x less than 0, y less than 0, but z greater than 0? What is a smaller region, right? So this is the region that x less than 0 is a very big region. But I want a smaller region. So how do we do that? Anyone? Just make some random guess. Yes. Yes, and then okay, so you say that, okay, I can try your command, yeah. Okay, so let me try exactly what you're saying. So if I put in exactly this command, but now for y, yeah, and this one is y, and z, and this one is z, and this one is z, and I run it. So this command, is it what we are trying to do? No, this one should be iz, yeah. Okay. Okay, z greater than 0, yeah. Okay, so now if I run it, what do I get? I get this region. Well, this one is not exactly what I want, right? Because this region is too small, right? Actually, I want, you see, so this one is like, it makes the whole, maybe eight part. So suppose we divide the sphere into 8 part, and then 7 part disappear, right? But actually, I want only 1 part disappear. Yeah. So what you are doing is like you combine the condition in the or, but not in the n. Yeah, what we want is n. Okay, so this, I think this region is not what we want. So what we want is so let me get rid of this one. Yeah, so what we want is the region that satisfy all the condition at the same time. Okay. So if I run this, yeah, so you see that this is the region we want, right? We want x less than 0, y less than 0. So this one is x equal -1 -1. So x is negative in this part, yeah. And then, combine with the condition z greater than 0. So then this should be this like spherical triangles. And we remove it. So Okay, so what you gave is okay, but I think it's different region. It's like the complement of this region. So what you give is the spherical triangle, but we want to remove that spherical triangle. Okay. So any more questions, comments? Yeah. It's okay, right? Okay, so we move on, yeah? So now the next question is how to solve a quadratic equation using the quadratic formula. Okay, so question, so can you explain x is 16,3, not a number again. Okay, so let me explain that again, yeah? So maybe before I explain it, let me show you what does the sphere command look like. And you will see what is going on here. So if you edit sphere commands, you see, so this one is the one that written by MATLAB people. So the sphere command is like this. Yeah. So this one is just checking the humans, not so important. But look, so their theta is from minus pi to pi. Yeah. So they have some parameterization. And the phi is between minus pi over 2 to pi over 2. Yeah. And then you see now they can compute x, y, and z according to the spherical coordinates formula. Okay. So if you look at this x is just a n by n matrix, right? Because if you take, so this is a row, and this is a, no, this is the row, and this is a column vector. So when you multiply it, you got an n by n matrix. Okay. Yeah. And now, so x 16, 3, this means that you just take row 16, column 3, and you make it invisible. You make it not a number. Then it's become, that point become invisible. Okay. So is it clear now? Otherwise, you can say, what is the, well, it is a point, I agree. But you see, if you look at x, if you look at the image x, yeah, so x, look like this. So if we, well, I mean, it is a point, but because, I mean, if you take a theta and you cut into only 20 pieces, right? Then one pieces is equivalent to one intervals, not a big point. Sorry, not a small point. So it's actually it's an interval. So that's why you see that has become a big rectangles. Okay. So if you want to see the point, you have to increase, like the size of a vector x, maybe 1,000, a million, or something. Then it will become a point. Okay, but now we use a very, very rough resolution. Think of your image. Yeah. If you use higher resolution, then one point is a pixel. But if you low resolution, then one point is okay, a big block. Yes. Okay, so now we move on to next question. Yeah. So next question is, now first we have to implement this function quasolve. Yeah. So now let me go back to MATLAB. Yeah. So first we have to implement the quasolve. So we take new function. So new function. Okay. And now, wait a second. So my new function is quasolve. Okay, so what does it do? So it will solve the quadratic equation ax squared plus bx plus c. Okay, so now what is the input and what is the output? So what is the input and what is the output for this function? So what is the input and what is the output? So I try to solve ax squared plus bx plus c. Yeah, so what is my input and what is the output? ABC, yes, should be ABC, yeah. So the input should be ABC, the coefficient, yeah. So A comma B comma C. So the input, just a coefficient A, B, and C, yeah. So you write A comma B comma C here. So then what is the output? Well, output should be X1 and X2, should be both, okay, because you want the output two roots. Okay, so you put X1 and X2 is the output here, okay. So output roots X1 comma X2. Okay, so now I have to put in X1 here and I put in X2 here. Okay, and remember the formula. So everyone remember the formula for the quadratic equation. So maybe we complete the discriminant first. So discriminant will be b squared minus 4ac. Okay. So we don't have to worry whether the discriminant positive or negative because MATLAB handle complex number. Okay. So we just put in minus b minus square root of dd divided by 2a. Well, if we are very careful, then we have to check whether a is a non-zero number or not. Okay, because you don't want to divide it by 0. So, but anyway, so just assume everything is very nice, so people don't try to break your computers. So you put in this formula, okay? So I think I should put dd, yeah? So this one is the discriminant, yeah? Okay, so now I have to save. So do not run it, because if you run it, it will report some errors because first we have to save exactly that the function name was solved, right? And now we have to create another script to test this function, okay, called quad test, yeah. So this is a script to test quad solve, okay. And so remember the first one is you solve x squared plus 3x plus 2 equals 0, right? So you say that, okay, a will equal 1, yeah. In this case, a equal 1, b equal 3, okay, and c equal 2. And then you just call the function quad solve. So x1, x2 equal quad solve a comma b comma c, yeah. And you can print out the results. So you can print out the results. So x1 is percent f is a floating point, yeah. So x2 is another floating point, and then you print out x1 and x2. Okay, so you run it. So this one, so save a quad test, yeah. Quad. Okay. And now let me run it. So if I run it, let us give some errors. So let me double check what is going on here. So fprintf, so fprintf is the command to print it out. So if I run it, you will see that the output will be, you see, so x1 is -2 and x2 is -1. It is correct, yeah? Because that is the solution of this equation, yeah? Okay. So any question? Any questions so far? So far, so good, yeah? So you see, solve is a function, yeah? So if you run it, it will report errors. So because it's asking for input, so then you have to write a script test in order to use the function solve, yeah? And so this is how you call it. And now the next step is actually the question asks you to write down a text file, okay? With this name, exercise 3.ii, which contain these lines. So you print out A, B, C, and then fx1 and fx2. Okay, so now how do you write out into a text file? Okay, so there's a command called fopen and fprintf, and then you can, so you see this one is you print out to the screen, yeah? Print the results to the screen, yeah? And now I want to print the results, print to a text file, okay? So first I have to use the command fopen. So first I have to use the command fopen. So fh is the file handle, fopen, and give it a name. So exercise vi, I, and I put in w, means that it will write, you see, it will have a permission to write, yeah? So write to the file, yeah? So remember when you open it, then you do something in the middle, then remember to close it. So F close in the end. Okay. So now how do I write into a file? Well, I use fprintf command again. Yeah. So I will fprintf, but the first yeah, so you see, it gives you the hint here. So the first input should be the file ID, the file handle. So FH, yeah. And then after that, you give the format. So now it wants A, B, and C. A, B, and C, yeah. So, but then, well, maybe we have to print out the line first, like this. So this \n, just a new line, yeah. And fprintf, FH, and then A, and B, and C, maybe B in the middle here, and C, and fx1, fx2, right? fx1, fx2. So that is the table, the first line of the, sorry, the second line of the table. Okay, something like this. And then, you know, we copy this again, yeah. So this one is the horizontal line, so copy it down here. And now we start to write down our results. So now fprintf, fh, yeah. And now ABC. So ABC given in the scientific notation, yeah. So we can give in scientific notation like this. Then fx1, fx2, yeah. So another scientific notation. Okay. Okay. So now we got ABC already, but we haven't computed fx1 and fx2, right? So we have to define. So we got x1 and x2 already, but we haven't got f of x1 yet. So we have to define f as anonymous function. So remember, anonymous function is just a single line. Okay. And it gives you the function right away. So a x squared plus bx plus c. Okay. And now you just put in f x1 comma f x2. Okay. And do not forget the new line here. Okay. So let me run it. So let me run it. So we have to save this, yeah. And now let me run it. So if I run it, so what do you see in the output? In the output, you don't see anything. Well, except x1 and x2 again. But now if you look into your directory, okay, if you look into your directory, you will see there is a new file called exercise 3ii. Okay. And if you type exercise 3ii, you will see exactly what we want here. So, so ABC, well, you have to adjust the output, you know, make it look nicer. Let's say this is A, this is B, this is C, this is f of x1, this is f of x2. Okay, so we printed out the first line of the table. Yeah, so you can repeat, you know, so you can repeat the command to print out, you know, another lines of the table. Okay. So any question? So we can set ABC to be, yeah. So maybe let me cut and paste. So you cut and paste this one, yeah. So here you don't have to print out the first two lines of the file again. So now you just replace the coefficient. So this one is a 0.01. So now a 0.01 x squared, and then the next question, the next coefficient is plus 2000. Okay, and then minus 0.001. Okay, so now A will be 0.01 and B is just equal 2000 and C is just equal minus 0.001, yeah. And then you solve it again. Okay, so you print out the results to the screen, and now you can print to the text file. So you just cut and paste this, exactly this two lines. Okay, you print it. So now let me run it. So, okay, so on my screen, you can see that, okay, so now print out x1, x2 for the first equation, and then x1, x2 for the second equation. And if you look into the output, you see now there's two lines. Okay, so this one for the first equation, this is a second equation. Okay, so this one is the first f of x1, this one f of x2. Yeah, so maybe let me stop the recording here, and then you can ask question. Yeah, so so let me stop recording.